Hi everyone, thank you for joining us for this session. I'm Manny Besso, I'm a product manager at Quali, and I'll be your host for today's webinar. With me here is my colleague Nama.
Hi Manny, happy to be here.
So today we're going to go over a fully automated CI/CD pipeline using Azure DevOps and our own CloudShell Colony.
Before we dive into details, let's first talk about the challenges that companies usually face when trying to build a CI/CD pipeline.
Great, so let's imagine that I'm a developer working on a new web application. From the moment I check in my code till it's in production, the code needs to be tested on different environments, and as the product grows, more and more people join the team, and they all need environments as well. They need to develop, they need to test, operate, support the product.
So this is where things usually get complicated, right? In terms of IT's ability to service all teams while controlling cloud expenses, IT often take ownership over all cloud infrastructure to control cloud expenses, and then they end up becoming the bottleneck holding back dev and QA. Another aspect is that very few professionals have the knowledge required to create infrastructure as code and update environments. This means that experts become a bottleneck in getting the environments the different teams need. Another challenge is where you have environments that were manually customized and no longer represent production. When tests run on such environments, they end up failing in production. Debugging is another challenge. It's usually difficult to debug the errors and determine the reasons behind a failed pipeline run. And then in terms of cloud expenses, they keep going up and no one in the organization knows why. Who is using the infrastructure? What are they using it for?
Right, so this is exactly why we built CloudShell Colony. We tackle all these issues head on. Our mission is to provide an environment as a service platform for DevOps. That on one hand enables teams and pipelines to get environments provisioned and deployed quickly and efficiently. And on the other hand, we allow the definition of roles and policies to control expenses and security.
Basically, CloudShell Colony allows its users to create blueprints that represent an application environment, create on-demand sandboxes from those blueprints to test the application during the continuous integration process, deploy similar environments to production, and continuously manage production upgrades. So how about we look into an example of a software product, follow its pipeline in Azure DevOps, and see how it integrates with CloudShell Colony.
Sure, so let's take a look into an example of an application that manages ad promotions. It's composed of a client-side and a server-side, and a Mongo database, and additional test data that is kept in its own repository and used in the CI process. The client and the server are developed by separate teams, each working on their own repository and providing their own artifacts. So, for example, when the UI developer commits code, a new build is triggered and a new version of the UI artifact is generated, and then to update the production with the new code, we need to create a new release with all the latest artifacts of all the components, and then run it through the pipeline and test it on different environments all the way to production. While testing, CloudShell Colony provides on-demand sandboxes, integrating with test tools and storage providers to pull artifacts, and then to update the production we use blue-green deployment strategy. Let's take a look at the release stages in our pipeline. The first step in a pipeline defines the artifacts we need for the release. They can be picked manually or automatically according to whether the release was triggered by the pipeline or manually. Then we run different types of tests, integration tests and UI tests. We actually save time by running them in parallel, and we use Selenium to test the UI. Load tests we run on a production-like environment with multiple instances behind load balancers, and the testing is done using JMeter. And then we run security tests using some third-party analysis tool to check for code vulnerabilities. When all these tests successfully pass, we run the backwards compatibility test. That one involves complex scenarios of data migration and usually it takes some time to complete. Let's drill into one of these pipeline stages and see how the pipeline starts a sandbox, runs tests, and ends a sandbox when done. We actually provide an out-of-the-box plugin for Azure DevOps, as well as for other CI and pipeline tools like Jenkins, TeamCity. Starting a sandbox is simply done by adding tasks from Colony's plugin and filling in the required parameters, like the name of the blueprint you want to use and the location of the artifacts in the storage provider. And then when your environment is ready, Colony returns all the environment details back to the pipeline, so you can extract any needed information and feed your tests.
And we also want to stress that environments can cost quite a bit of money. So with CloudShell Colony, we made it a point not to leave cloud infrastructure up when it's not in use. So once environments are no longer needed, they are terminated.
Yes. So let's continue with the production. For the production, we use a blue-green deployment strategy, which means that we deploy a new green environment while keeping the previous one up and running. Then we wait for manual approval and promote the release. This will cause traffic to gradually shift from the old version into the new version. Now let's run the pipeline and see how it launches the environments using CloudShell Colony. We are now in CloudShell Colony and we are looking at the sandboxes that are being created by the pipeline. Each sandbox has a cloud parameter that indicates where it's deployed, start date and end date that control its life cycle, and the blueprint definition that was used when the sandbox was created.
Other than Azure, CloudShell Colony also supports AWS and Kubernetes, so you can launch sandboxes on any combination of cloud provider you need. Let's talk about what users can do when they need environments outside of the pipeline. For example, how can a user manually create environment sandboxes to reproduce a customer bug or run a manual test procedure?
Sure. So we're now in my CloudShell Colony account and I'm logged into a shared space which I'm a member of, along with all the rest of the team that's working on this product. That includes developers, DevOps, QA, and anyone else involved. And as you mentioned, in many cases, team members need an environment outside of the pipeline, like, for example, to run manual tests for issues that can't be automated. CloudShell Colony includes a self-service blueprint catalog, so any user can simply access the catalog, enter the duration for which you would need the environment, fill in some parameters, and instantly create it. Now that we created a new sandbox environment, let's open it and see it get deployed.
While the environment is being deployed, can you elaborate a little bit about the deployment steps that are now happening in the background?
Yes, so there's actually a lot going on right now in the background. First, the infrastructure is created, including networking elements, compute instances, security definitions, and so on. Next, we prepare the artifacts by pulling them from the storage provider and making them available for the application scripts. Then every application is deployed separately and in parallel to the other applications. And finally, we run health checks and make sure that the infrastructure is stable and the application is ready. The deployment ended and the sandbox is active now, so let's talk about what it contains. We have the Summary tab with general information about the deployed environment and quick access links to the deployed application. Just click a link and you're in the app. The status of each deployed application is displayed in the Application tab, along with additional useful information like open ports and DNS names. The infrastructure that was created for your environment on your cloud provider can be viewed in the Infrastructure tab. So you see we provide a full picture of the environment from the application point of view and the infrastructure point of view. And let's talk about the debugging challenge you mentioned earlier. So we know that debugging can be a real pain. So to make it easier, we added a special debugging tab where you can view the deployment status of each instance separately and then use a remote gateway to connect directly to it, using SSH or RDP to connect to the instance, and then once connected, just run a single command and print out all the deployment logs. Now let's go back to Azure DevOps and see how CloudShell Colony helps with the production upgrade. Our pipeline is all green now, which means that all the tests passed successfully and CloudShell Colony deployed a new green production environment. Let's open it. We can see that the green environment shows the details of the new release. Right now, the green environment can only be accessed when browsing directly to the green host in the URL. Let's compare it with our current production environment. You can see that it points to an older release number. Let's complete the production upgrade by shifting all traffic from the old version to the new one. In our case, we define a manual approval gate to complete the upgrade. Great, so we've completed the production upgrade, and now all the traffic goes to the new release.
We've seen the Blueprints catalog and how it can serve all team members to manually launch sandboxes. So how about we look into how a DevOps engineer would create a catalog for others to use, and we'll start with how you model an application and create a blueprint.
Well, blueprints and applications are both source-controlled YAML files. We figured that your product changes with time, so the environments you use should change as well. This is the reason we found it important to allow engineers to track the history of blueprints and be able to roll back to earlier versions when needed.
So basically, the first thing to do when developing a blueprint is to connect the source control repository with CloudShell Colony.
Exactly. So in your Colony settings, you connect two repositories, one for blueprints for sandbox environments and another for production environments. And then you can start developing blueprints. Let's review the blueprint that was used by our pipeline for load tests. The blueprint file includes artifacts, inputs, and all the applications required to create this environment.
We can see here that applications can be easily mapped to relevant infrastructure, meaning that you can model your application once, and then with just a few changes to parameters, you can switch between deploying them to a single infrastructure instance or multiple instances.
Yes, and modeling your application is done by creating the application YAML file, which is the recipe CloudShell Colony uses to deploy and configure the application. It defines the required infrastructure, the networking requirements, and points to scripts needed to configure and check the deployment status.
It's important to note here that CloudShell Colony's blueprints don't necessarily have to replace existing assets you currently own, because we integrate with different DevOps tools and provide a controlled self-service catalog on top of your existing DevOps assets.
That's right, so going back to the blueprint development, when blueprints are committed to the repository's master branch, the user responsible for the cloud budget can publish them and make them available for end users to use when creating a new environment.
Looks like we covered everything. We've seen that environments take a crucial part in building stable application pipelines and in DevOps processes in general.
Using platforms like CloudShell Colony enables teams to quickly get fully provisioned and deployed environments, while keeping cloud expenses under control.
If you want to learn more about CloudShell Colony, please visit our website.
Thanks for joining us today.